Hello, YouTubers. Today I'm going to talk to you about some interesting concepts when it comes to object-oriented programming and how does that relate to channels in C Sharp 8 with .NET Core 3.1. Just very recently, the .NET team announced that channels are now an official part of what is being shipped with .NET Core 3.1. And there was a very interesting blog on Microsoft official blogging website where they talked in detail about channels and where channels come from. Channels are very popular with Go programming language developers, and it was just introduced very recently for C# developers through .NET Core. But channels, when I was looking at channels, the first thing that really inspired me to make this video and talk about channels is basically channels seem to be applying what Alan Kay, the inventor of the concept of object-oriented programming, intended back in the 1960s, somewhere around 1966, 1967. His idea about object-oriented programming is that objects should communicate with each other through messages. And then if you look at how we build our objects today in our classes and our business and enterprise applications, you will notice how far, the development and the evolution of software have gone from the original ideas of Alan Kay when it comes to object-oriented programming. When I looked at channels, I said, that sounds like something that Alan Kay would actually really appreciate. When it comes to building objects, these objects absolutely know absolutely nothing about each other. All that they know is that they send messages, and whoever is interested in these messages will pick up that message and start processing it. Now, why is this important? Let's go into the details of why channels are important and why, like today, we talk about dependency injection. Yeah, you implement an interface, and this interface will be passed in the class, and then the class will manage, using that interface to communicate with particular methods and all that kind of stuff. But there's a problem with that. Even though the dependency injection, it abstracts away the implementation and it makes it easy to inject, dependencies as long as they conform to the interface, there's still a slight sense of coupling that's going on there when you're building your class, because the coupling here is based on the actual interface itself, right? Okay, we abstracted away the actual implementation. Everyone have to adhere to this interface in order for this class to actually be to run. But the reality of the situation is that if you decide to change that interface, that means you have to change the class. And if you have to change a class, that means you have to touch the implementation, right? Even worse, if you want to actually apply the concept of being open for extension, closed for modification, that means you have to entirely inherit an entire new class, implement an entire new class, call it V2, V3, whatever V you want to call it, and then implement and then write an entire new interface with a new version, and then deprecate the older class, and then you have to send an announcement and tell your clients this is deprecated. It's such a pain just to change a couple of parameters, maybe on a method that you're using to send a message out there to communicate with a broker that will put a message on a queue or whatever the case may be. So channels are very interesting in the sense that let me pull up here a little bit of design. Um, uh, Let me share my screen here real quick so you get to see what I'm talking about particularly. So let's put things in a little bit of visualization, and then we'll talk about, in a little bit about, okay, so here's a design situation that we have. So let's say right now we have a bunch of classes. So let's say you have class A. Pull that guy a little bit closer so people could see on their cell phones. And then you have class B. And then class A and class B, in order for class A to do something with class B, it goes and, calls a class B, right? Or an interface that class B implements, and then the interface gets injected. And somehow, in some way or another, class A knows about class B. It knows about class B. So I can't interchange class B unless I have to have it like, okay, the real situation here would be an interface B, and you have a class B that actually implements that interface like this. A little bit. Class B. So interface B, this guy is saying I'm only confirming to this guy, and then later this gets injected into class E, and they all know about each other, right? They all know about each other. So class B knows about interface B, and class A knows about interface B. So when class A is injected in class A, you know, class A lights up and starts to work. So that means if I'm having a method in here, let's say do something, then in order for class A to run, do things, it has to go and say, give me that instance that you have available of class A. So this dot class B dot do something. See what it is? So if at any point in time I want to change this method, I have to change this method, and I have to change this method, or I have to create an entirely new implementation. This really sucks. This really sucks because, you know, while we say, okay, we have dependency injection, so you could have class C that implements interface B that can be injected in class A, you're still really heavily dependent on minor implementations that are required by interface B, right? But that's not really what Alan Kay intended when he invented the concept of object-oriented programming. That's completely outside of what he really wanted to happen. What he wanted to happen basically is that he wanted a bunch of classes that know absolutely nothing about each other. Absolutely nothing, no interfaces, absolutely nothing. And what these classes are doing is that they're sending messages to each other. So regardless, let's imagine there's a pipeline in here, like a queue. And this queue is like this. And these messages, these classes are basically sending messages to each other accordingly. So these classes, as class A and class B and class C, you know, they really don't care about, you know, how you're implementing it, what kind of method is picking up the message. They don't care about none of that. All they know is that they need to put a message on a queue, and they need to wait for a message to be picked up from that queue. So that would be the sending of the message and then the response of the message, right? So that means class A and class B and class C are truly decoupled from each other. Are truly decoupled from each other. Someone might tell me, but there is a little bit of something in there. I said, what is it? He said, well, don't you have to understand the model of the message? Don't you have to be tightly coupled to the model of the message? I said, yes, that's absolutely 100% true. And because of that, I mean, if you think about it in real life, you know, someone has to somehow know how to format a mail message in order for them to send that message to you. This mail message has to have particular formatting, like an address, maybe a stamp, maybe it has to have an envelope. So that modeling, you're still somehow coupled with the contract, but not how this contract is being like how this contract is being processed, and not how this contract, where this contract is coming from. So at any point in time, I could replace class A with class B, C, D, E, and I can change the function completely, and I can change the name and the parameters and everything, and none of my consumers have to know absolutely nothing about it. This is absolutely true implementation of decoupling, right? But people say, okay, talk is cheap, right? Show me the code. What does the code look like? Let's go ahead and start a new C# application, and let me show you a very simple example of how that stuff works. So let me create here a new project, console application. Let's say Alan K is genius. Excuse me. All right, here is C Sharp. Let's make that font as big as possible for people on their phones. So let's talk about this for a little bit, right? So what's the deal here? Let's go ahead and start by just saying channel. Channel like this. Let's make sure we're using .NET Core 3.1. So if you look in here, you'll see so .NET Core 3.1. Great. If I do control period, channel comes out of System.Threading.Channels. I want you to remember that namespace very well because that's what you're basically going to be using. So let's say this is channel, and I'm going to initialize my channel in here like this. And I'm going to create a channel out of this, and I'm going to dictate what kind of contract, what kind of message that needs to go back and forth. So instead of knowing who's creating the contract and what kind of method that's giving me the contract, I'm going to go ahead and just tell it this is the type that you're supposed to be picking up and processing, right? So I'm going to create unbounded channel like this. And this unbounded channel, let's say the contract here is string, which means that this guy here is a channel for strings. So what you're sending in here is basically a bunch of strings, right? So let's see in here, and there's a bunch of options. Let's see, bounded channel options. Sorry, we want to create unbounded channel. Create unbounded channel, right? No limitations, unbounded. You can do whatever you want. This is great. All right, so I created a channel. So this channel here would be the resemblance of this guy. This guy is my channel right here. Now, let's have a function. That's funny. Let's have a function that a class that puts a message on this channel, and then another class that picks the message from this channel, and then a third class that reads the message, right, and actually does something with that message, right? So let's start with putting a message in that channel. So let's say in here, I'm going to go and say channel dot writer, and then write async, and then I'm going to put a message in there. So this is me writing to that channel. I'm saying this is a message. Obviously, because this is C# 8, you can actually go and say task async task. Unfortunately, you can't say main async. You have to keep it as main. And then you can go in here and say write async. So let's write something in here. Let's say Hassan, this is a message. All right. And then let's have someone read that message from the queue. So I'm putting a message, and I'm picking up this message, and I'm putting it somewhere else. So let's say this is the message, and this is await channel dot reader dot read async like this. And then I'm gonna go here and just do console write line. I'm just gonna print out the message like this. All right, there's no magic there. We're gonna expand on that example in a little bit. Let's just have you understand the really bare bone of what's happening. I created a channel, I put a message on that channel, and then I read the message from the channel, and then I printed the message out. Is that how it works? I don't know. Let's find out. Running my code. There you go. So it picked up the message, it read my name, and then it went in and processed that message, right? Now let's see what that looks like actually in the real world. If I want to actually have 3 classes, right? And let's just resemble, I don't know, a tea-making team, like a team that's going to collaborate together to make tea. So someone is going to boil the water, someone is going to get the tea, and someone's going to join the water and the tea together to make it work and make a cup of tea. I use tea as an example because that's the only thing I know how to make. So let's create this. Let's create 3 classes in here. And the first classes would be the water boiler .cs. So that's a person that boils water, right? And this water boiler This water boiler doesn't really do anything other than boiling the water and just putting it on the message on the queue and saying here's the boiled water, right? And let's create another one that says the tea buyer. This guy's gonna go and buy us some tea bags, right? And then the last one in here will be the tea maker. Tea maker. So this guy here is gonna pick up the boiled water and pick up the tea bags, and make the tea. All right. So let's add functionality for this. This tea buyer in here, sorry, let's start with the water boiler here. I'm going to write a function in here. I'm going to pass to it a channel in its constructor. Right, here's a private read-only channel. See, all it knows about is just the channel and the contract. I wonder if this channel actually, yep, so channel, and then in here, you're passing the channel. If this channel implements an interface, that would be even better. No, it doesn't. Okay. Let's pass that channel here as an input parameter. And then let's assign that, since it's only a one-liner. Let's say this dot channel equal channel. So I have a channel, right? So I taught my water boiler about where to put the water when it's boiled, right? So let's go here and let's go and say, okay, we need to create a method, and this method will basically say void boil water async. So this guy in here is just going to boil some water. Value task. And boiling water meaning it's just going to go in here and say, this guy is going to go in here and say this dot channel await this dot channel dot writer, and then write async. It's going to say water boiled. Okay, water boiled. So it's going to boil some water. I'm going to put it out there. Perfect. Let's go to the tea buyer. The tea buyer is very similar to this guy. We're going to copy all this work. I'm going to go to the tea buyer right here. I'm going to say buy tea async. We have all that good stuff. Water boiler. This is going to be a tea buyer interface. And then tea bought. So this guy bought tea, and the other guy boiled the water. And then let's go to the tea maker. And this is a little bit different. This guy is going to have an interface. It's going to have a look and feel just like everybody else. But the only difference is that this guy will be sitting there waiting and listening, waiting for the water to be boiled and for the tea to be bought in order for it to start making the tea. So let's go here to that tea maker. Here's a value task. And this here is that make tea async. Right? And what this guy is going to be doing is that it's going to just put a message there that say tea is made. But this guy can't make the tea unless the parameters that it's looking for, you know, the water boiling and all that, is already done. So what we're going to go do here is that we're going to go and say make tea. And we're going to go and say while this dot channel dot reader wait to read async. So this guy will just be waiting here like this. And this guy will be waiting to read. And as soon as it picks up a message, it will only make the tea when both the water and the tea are there. Right? So what does that mean? I could go here and say and verify. I could go here and say Boolean is t here equal false, and Boolean is water here equal false. So this guy didn't receive the water or the tea. Now we can go here and say if, and we're gonna read a message, right? If, let's try to read the message. So here is a message equals, and what this guy is doing basically, it's saying this await this dot channel dot reader dot read message read async, right? And then we'll go here and say if message equals water boiled. How did we write the water boiled? We put it in there, water boiled. Yep, this exact guy right here. The water is boiled. Then go ahead and say is water here equal true. However, if the message equal t bot, I think we put it as t bot. Yep, like this. Then what's going to happen is that we're going to say is t here equal true. All right, let's see what this guy is suggesting. Right. I don't know what redundant assignment is it talking about. And then, so okay, so if we have both of these, right, you have that while loop, right? You could go here and say, in your iteration, you could go here and say, once these two are done, let's go ahead. If you have the water here, and if you have the tea here, all what you can do is that you can go here and say, if, right? You can go here and say if is water here, and is tea here. You can go and say tea is made. You're basically writing a message on the queue, just like that. So messages being sent between multiple objects, right? And this guy is going to pick up that message and run with it, right? So let's see what that looks like. Let's see what that looks like. In fact, I'm actually, instead of doing this, I'm just going to print this out. I'm just going to go here and say console write line tea is made. This is a guy that's waiting for that to happen. How do we instantiate all that stuff? We already have our channel right here. Now let's instantiate our objects. So we have var water boiler equal new water boiler and takes in the channel as a parameter, right? And then we're going to tell the water boiler boil some water. Wait, boil some water. That's one guy. We have in here the tea buyer, new tea buyer, also takes the channel. See, the tea buyer doesn't know anything about this guy. They run on their own and they are exchanging messages. So in here we'll say await tea buyer dot buy some tea. The last guy that we have here is basically var tea maker. And this tea maker will say new tea maker, also takes in the channel. But the difference is that this tea maker basically makes tea and it doesn't take any parameters. I could change the implementation of any of these guys and I don't have to change other than the class that I'm working with. Only the class that I'm working with. If we even unify the trigger function, it's even better. You could just say run, and whatever it's doing under run, who cares? Nobody cares. Let's see, does that work? I don't know, it's just a theory. Let's run and see if that works. T is made. You see that message? T is made. What does that mean? It means that we basically that these messages communicated, these classes communicated with each other, right? And eventually the T maker, when they received these messages, regardless of what happened, and I'm going to show you right now how awesome this is, because I could change anything in my class. I could completely have an entirely new class, that does the same thing, and it wouldn't change anything across all the other entities. Like, for instance, I can go in here literally and go and say, oops, hold on. I can literally go in here and say, here's a completely new T maker. Sorry, T buyer. A completely new T buyer that does things completely differently, right? And this completely new T buyer could have the exact, obviously we just subscribe it to the same channel like this, but the difference is it has its own little way of doing whatever it wants to do, right? Like it could literally have a function that says public async task, value task, buy something, like this. It's buying something, whatever that something is, right? And I could go here and say, okay, this buy something, right, guy, can go here and say write writer write async. And in that write async, there is something that is being changed in here, and I'm going to wait this guy. I completely changed the implementation of the class that actually buys T. Completely, right? But it still adheres to the same contract regardless of the implementation behind the scene, right? And this is the slight bit of coupling that needs to happen. In real life, there is a little bit of coupling somewhere. You can't go buy a cup of tea if it doesn't look like a cup. You have to adhere to some sort of standard that when I look at something, I say, yeah, this is a cup. I can drink this. I can buy this because I identify this as a cup. It has a handle, it holds things in it, and all that kind of stuff, right? So if I go into program in here, and I completely new T buyer, and I have a completely different contract, and this guy basically say buy something, it doesn't impact any of the classes that are directly dependent on the message that this guy sends in any way, shape, or form. I could just go here and say T bought, right? I changed the implementation, right? But that did not impact this guy. It did not impact this guy in any way, shape, or form. Let's see if that's true. I don't know. It's just a theory. Is that real? I don't know. Let's find out. So if I run this guy now, the result is still T is made. This is Alan Kay's dream of having objects in object-oriented programming to be completely and utterly separate from each other, right? As long as they adhere to some sort of a contract. For instance, let's say you have, let me tell you this. Let's say you have a class that requires you to make two calls from the same class. Let's say you're going and verifying if something does exist, and you're going and verifying, and then maybe you're going and updating that thing. So you verified that exists first, and then you're updating it, right? There are two calls. And then someone went and said, okay, we're going to change the implementation. We're going to have it say, upsert function. Upsert function. If the function is there, insert it. If it's not there, update. If it's not there, insert it. And if it's not there, and if it's there, update it, right? You have to change your implementation here from calling two functions to change one function. And you have to change your interface, and you have to change a lot of things. So let's say you have, for instance, you have 5 different classes that are all using the same function on the same class. The ripple effect, because of the dependency there, is very costly and unbearable sometimes because the application is too complex, right? When in reality, if you have these objects sending messages to each other, it makes things a lot easier that you don't have to worry about how things are implemented, but not even how things, what you need to call to implement something, but not even who's reading that message, right? You can detach and attach a completely new class and a new implementation that completely changes how it implements things. It requires a completely different set of input parameters. But as long as that class knows how to read that object and adheres to that contract and works with it, no other class have to worry about it completely, right? For instance, if you notice that in here in a completely new T buyer, if this guy had actually a dependency on this guy, then this guy have to have this guy as an input parameter, T buyer as an input parameter. And now you have to go in your T maker and say something crazy here like this. This.T buyer.byT async. And then when you change your T buyer, you have to change that implementation and it touches every other class that you're working with. It's horrible. It's horrible, right? So there are some really interesting articles that are published on the internet. I'm gonna reference a bunch of articles for you, but this is here for you, and you can have this in the you're gonna have this article in the comment section. This is Alan Kay's definition of object-oriented. It's a pretty interesting little blurb of information. He actually went deeper than that. You have to read the books and the articles. But if you can see the second principle, he said objects communicate by sending and receiving messages in terms of objects. So they're sending and receiving messages. That's the implementation of true object-oriented programming as Alan Kay intended it to be, not the way how things are implemented today. There are some challenges with this approach. There are a lot of challenges with this approach. There are challenges like can you actually run everything asynchronously? What's the cost? What's the memory cost? How do you do this in an ASP.NET API? For instance, if you want to initialize all these classes and just set them loose from startup.cs, right? If you look at the real life scenarios of things, let's say you want to visit a friend. You don't go and create an instance of a friend and then call the friend with a method and then tell that method visit me. That's insane, right? Instead, you send a message and the friend picks up the message and say, he's asking me to visit me. It's more realistic. It seems like Alan Kay's original idea was actually a lot more realistic than how we're implementing software today. One more interesting article that I want you to take a look at is basically the .NET blog by Stefan. You can see here a lot of details about channels and what you can do and what you can't do. You can actually branch out and have multi-threads and run that in your in different implementation. It's a very, very, very good article. I went through this. I learned about it a lot. He's pretty straightforward about, when he talks about channels, where channels come from, where the inspiration came from. It's a very interesting article. There's also another one in here. And that second one is actually really, really cool. I think it's this guy. Yes, this here is gold. This here is pure gold. It's published in December 2019. A little bit of overdue subject, but this article here is actually one of the best that I have seen so far. It shows you every single with illustrations. It shows you how to merge messages with each other, how you listen from the other side, how do you split a message. You're basically publishing and sending to a bunch of people. It's like the pub sub model or publisher subscriber or observer pattern. How do you just send a message and a lot of people would read the same message and all that. It's a really, really interesting article that I really highly recommend. So you have Alan Kay, definition of object-oriented programming. You have Stefan's article, and I honestly didn't even know, the name of the gentleman that actually wrote, Dennis Kaishif blog. It's a very, very interesting article that is really worth reading. The thing about software is that it always changes. You have to continue to learn. You have to continue to try to make like software in general is just the idea of modeling a real life scenario and extracting that model and putting it on the computer so the computer can run a simulation. With messages and stuff like that, it makes it a lot easier to model and simulate software. The more simple the software is, the more realistic it is, the more adhering it is to patterns in real life, the more easier it is to actually engage your brain in the problem solving instead of worrying about the little minuscule details about the implementation and how this is supposed to be implemented and how that's supposed to be implemented. It's more like mirroring. Ultimately, when I teach people programming or when I, train people to work with particular patterns, the ultimate goal here for a software engineer is that you're not even looking at the code or thinking about the code. You just have an idea, and this idea gets implemented immediately in the code. How do you make it happen in the code without thinking too much about the implementation? I think this is a very interesting approach. I think it's worth your time to look at it and, think about how can you use this in a real life scenario. And hopefully in more upcoming videos, I will show you maybe how you do something like that and something more business related. How do you put that in a real life application, actually benefit for it? Definitely back-end processing services would be the biggest, things that benefit from a channels, because if you're basically building a backend service that does data migration, for instance, so it's reading from a CSV file and then mapping that CSV file and then adding that CSV file in a SQL server, this is perfect for that. But can we extend it a little further? Can we make it better? Can we put it in APIs? Can we put it in web applications? What would that look like? That's pretty much it. I really appreciate the time you take to watch my videos. If you have any questions or comments or concerns, please free to leave a comment in the comment section. And don't forget to like and subscribe. And thank you for watching. I'll see you in another video.